Hey guys, welcome to another episode of Bob's Woodshop. I'm with my good buddy and club member, Bill Schaller. Say hi, Bill.
Hello.
Hello. I'm down at his shop and we're going to show you how he made these little coloring lathes. It's a little miniature lathe that we're going to use to color these tops that we do for the children's hospital. So Bill's going to take us through the design and some of the assembly process and a little bit of 3D printing. So let's get started. You ready to go, Bill?
Let's do it.
Okay. Here's the little lathe that we're talking about. This is Bill's creation. He designed all the different parts. And these are some of the tops that we're going to be using. So Bill, explain this little invention to us.
So we want to let kids color their own tops because it's a really exciting activity. And we wanted to make a way for them to do it safely. We don't want them touching a big lathe. So this design was based mostly on my own imagination, but I also kind of patterned it off of lathe tailstocks that I'd seen in the past. So tailstock fully works, the quill advances and removes. And then we have basically a chuck here to hold the top in place.
Yep, so what all is inside the, we got a motor and what in here?
There's some electronics. There's a PWM motor controller and a 1000 RPM motor, DC motor.
Okay, so that's going to be the headstock and this is going to be the tailstock, right?
Yep.
And you got a bunch of components. How many? You got like how many parts in all these things?
There's 11 3D printed parts and 2 turned parts. And then there's the board that controls the electronics. There's the motor, and a couple of pieces of power equipment, and of course the base here and some screws.
Okay. So go ahead. Let's see it work. I forget, it's a speed adjustable?
Yep.
It is adjustable, okay, cool. So that's how we're gonna have kids color the tops. Like Bill said, we're not really crazy about the idea of turning the lathes on and having the kids color on the top. So when we do our demonstrations at the different shows that we do, one's gonna be this weekend at the Environmental Center. We're gonna have the children color their own tops here. So, okay, what's the next step of the process, Bill?
Well, let's go take a look at the design.
Okay.
I designed this in Fusion 360, and I started with the motor. I designed the whole headstock end around the motor because I knew I couldn't build a motor, but I could buy one. So I bought a motor off of Amazon. I looked for 1000 RPM because I figured the torque on it would be pretty low and the experience of a high speed would be pretty good for the kids. So I started with basically this little faceplate that holds onto the motor at the headstock end. And then I just kept going from there. I knew I needed a plate to mount it. I knew I needed everything to be coaxial so that the tailstock lines up nicely with the center of the motor spindle. And so that was kind of the foundation of all of it. Inside, you can see my mock of the motor, and then a place to mount all the electronics, a place to have the knob come out, and all the other bits of this thing. And then the tailstock, I used to have a jet lathe, and having assembled and reassembled the tailstock before, I used that sort of as the mental model for how to design it. And this went through a couple of versions. It turns out to be a little complicated to make a tailstock, a little more complicated than I expected when I first started. But after about 3 or 4 versions of it, it turned out pretty good. The knob at the end, that's a pretty simple thing, but once you get inside, there's a couple more pieces to hold a 3/8 hex bolt. Inside of a jet lathe tailstock, there's a fairly large bolt that the quill comes in and out on. And I couldn't, of course, find that anywhere, so I figured why not just use something I can get off the shelf. So inside, it's all designed around a 3/8 hex bolt. The front end of it, the quill, is designed to retain itself. With the jet tailstock, you have basically a screw that keeps it in place, but this top bar along the quill here keeps it from rotating inside. And at the front of it, it's designed to hold a bearing. It's not a perfect design, but it works pretty well for our purposes. And then of course the base I designed to be laser cut. It's just 2 pieces of laminated 1/4-inch plywood. And that's about it. This took about a week and a half, start to finish.
The total design time, about 60 hours?
Yeah.
That was it? Okay.
Something like that. Yep.
And you got the motor housing, right?
Yep.
So that's one, two, three pieces?
Yeah.
Okay. All right, so once the design's done, how do you get it onto the 3D printer?
So the 3D printing, that happens using a slicer. We export each of these models as what are called STL files. And then I can import it into this program called Cura, and then I can slice it. So I can put that onto the build plate.
I'm sorry, what do you mean by slice it?
So 3D printers operate in layers. They lay down plastic in layers. And slicing it refers to cutting it up into these individual layers that are going to be printed. So one by one, the printer will lay down each of the 3D printed layers, and you can step through the process.
Wow, okay.
So once this is sliced in Cura, I can export it onto a chip here, and then I take that over to the 3D printer, and we can put that in. I've already got it in there, and then we can print that. It'll warm up, and then it'll start printing.
So this is a relatively small part. How long will it take to print that?
About 20 minutes.
Okay. So you said this part's going to cost or take how much time?
About 20 minutes.
20 minutes. All right. So again, we're not going to video all this, but you get an idea what's happening. So let's go on to the next step. Bill's going to explain the various parts of what he designed. So this is the part we're printing right now, right?
Yep. So that's what we just started printing, and you'll see that there's this honeycomb shape here. This is support material. Because the thing is hollow on both sides, and it's got this part in between, it needs to be able to support it while it prints. So this material is breakaway material, and you can pretty much just pop it out. There's a little bit of cleanup on these parts to make them fit well, and part of it is making sure that these support material come out nicely and don't leave little burrs and edges. So that's cleaned up, and the part that's going to fit with is the quill, which is right here.
Okay.
So that, you can see that's already put on there. I put that on there and glued it on, because glue takes some time to dry.
Do you using CA glue?
Let's talk about glue. So the glue that I'm using is called E6000. CA glue doesn't work that great with 3D printed parts. Okay. It tends to disconnect, and it also fumes. But this E6000 works pretty well. This is what most people recommend to use for 3D printed parts.
Okay.
There's a couple of parts that have been glued together here, like this. You'll see in the end here, I've got a 3/8 hex nut. That's meant to engage with this part. So this is the bolt that I'm going to use for the tailstock, and that's meant to go in there. And here's the tailstock body itself. And you'll notice one thing when I put this in here, I'm holding it against the end, and you'll see that it's not quite centered. So it turns out that a bolt that you buy from Home Depot, for instance, is not perfectly machined. If you stand it up, you'll notice that it's just leaning ever so slightly in one direction or another. And in addition, this surface is not perfectly perpendicular to the inside edge of this head.
That's pretty typical on all bolts?
That's pretty typical. So if I stick this guy in here, you'll see, oh, well, this one's actually pretty good. But a lot of the bolts that you buy are going to be imperfectly machined, which is fine. One of the things you can do is, if you find that it's leaning to one side or another, you can take a Dremel and you can shave down parts of this to make it fit well within the 3D printed parts so that it goes straight. And that's what I did here. This bolt was really crooked to start with. It's not perfect now, but the thing you're trying to avoid is like super crooked. You can deal with a little bit of out of tolerance here, But the more it is, the harder it will be to advance the tailstock. Another thing here is that these parts, once they come off the 3D printer, you want them to be fairly tight, but they will be too tight when you first pull them off the 3D printer. So you'll notice that this part right here is smooth. I took a file to that. I also took a file to the inside channel here, and also just to the inside of this in general to make it smoother. 3D printed parts, they have lines along the edges. So you want to file those down on the parts that are mating. And we can also use a little bit of lubricant. So I actually use some food safe lubricant. Doesn't have to be food safe, but it's just a petroleum-based lubricant of some sort to make these things slide nicely together.
Okay.
So let's talk about the lid. The lid that I first designed was this one. It's rigid. It was the soundboard. The motor would make a really loud noise that Bob complained about. So I redesigned it so that it's a rubber piece, and this damps the sound pretty nicely. So that's all about the parts here. So let's quickly go through the electronics piece. Let's talk about electronics. So this is a DC motor. It has a gearbox. It's a 1,000 RPM gearbox. This right here is an off-the-shelf part, and it's called a PWM motor controller. I got this from Amazon. They used to sell a different model of this, and then they started sending this one instead. The motor housing is designed for the different model, so it doesn't fit perfectly, but it fits good enough for our purposes.
So when you buy this, are you buying the motor controller and the motor at the same time?
Yes.
Right.
So those two parts together cost about 25 bucks.
Okay.
So this is the speed knob, and this just goes through here and it's connected like that. I like to solder some wire onto this motor and then connect it, tighten these down. You basically plug them in, tighten it down. All right, so we'll go ahead and connect these up and do a little bit of soldering to connect that motor.
What's this one?
So this is actually a jack.
A jack. Okay.
I didn't want to have wires sticking out of the back because you never know what kids are going to do.
Right. Okay.
So it's basically a fast release for the power jack on the back.
Oh, okay.
Okay, so we're going to go ahead and assemble this. The first thing we'll do is solder that motor together. Soldering iron here. All right, we're going to pick some wires here, and then we're going to strip them. And we're going to solder them on. So the first thing we want to do is tin the connectors. Otherwise, nothing will stick. So what we're doing here is getting some solder onto the connectors here. We want the wire to stick when we try and attach it. So we need to get it wet with some solder. We might need some flux. That's what I think I'm going to do there. So we're basically tinning the connectors so that the wire will stick to them. Alright, get a little bit of solder on there to start with. And we'll stick those wires in. You've got to pay attention to what says plus and what says minus. That's plus and that's minus. We'll put the red on the plus, as you might remember from
Car
high
batteries.
school, car batteries, wherever you learned it. So that connects that. And we'll do the minus. Same deal. All right, so there's our motor.
That's all there is to it?
All ready to go. Just gonna twist these wires a little bit so they don't come off. There we go. All right, so that's ready to connect up to this board. The board, it tells you where to plug everything in. It says motor minus, motor plus, and then power minus, power plus, and that's all there is to it.
Okay.
So all we need is a screwdriver, which I've got right here.
Cool little set, little micro set, screwdriver bits, very
So
cool.
those at Micro Center or anywhere pretty much. I think they have them at Home Depot too. So we loosen up all these connectors. And like so. And then we can connect the motor. So the motor plus is there, motor minus is there. Connect up. Oh, I forgot to strip it. Plug in the motor minus here, and then tighten it down. Motor plus. All right, now we are going to stick this here, and we'll want to connect this through here. Don't forget.
Let's talk about the jack, yeah.
Yeah. So this jack right here is to allow us to have that sticking out the back and then plug our power connector into it. Just like this. That's so that if the kids go a little nuts and knock it off the table, it's not going to do any damage. It's just going to break away. But do not forget to put this through here before you connect it to the board. Otherwise you're going to be mad.
Okay, so don't forget to attach the nut before you connect it also.
Yep.
So basically, not a whole lot of connections, a little bit of soldering, and then the screw terminals.
It's pretty straightforward.
Yeah, not a whole lot to it.
Now if you wanted to make the controller yourself, well, more power to you, but that's not something that I want to mess around
Well,
with.
it's really not worth the effort for these motor controllers are pretty inexpensive.
Yeah.
You have to be comfortable with fiddling around in small spots in order to do this, but as long as you can do that, it's not too tough.
There we go. All right, so this is just a DC power adapter, 12 volts.
Okay.
To run with the same
These are
voltage.
pretty inexpensive. These are like 20 bucks.
Yeah. Actually, this one was probably about $6.
$6. Wow.
Yeah, so they're pretty cheap.
It's amazing.
Yep. So it's not a very high build price here. It's a pretty cheap build. So we're testing this out, make sure that works. Make sure the speed controller is working. Yep, so our motor's running. Everything seems good.
That's very quiet.
Yeah, it gets louder once you have all the parts attached to the board, because it's got this. It's basically a soundboard effect. It also gets louder once you put a little bit of back pressure on the
Some load. Put it on under load.
Yeah, once it's under load, it gets a little bit louder. All right, so everything works there. Now we're going to glue down the board. And actually, one of the things that I'm going to do is make sure that the motor is going to turn the right direction. I don't remember what direction it needs to turn, but we're going to have the kids standing on this side. And we're going to have the motor here, and we want it to be turning this way.
Turn counterclockwise.
Yeah. Well, actually, we want it to be turning clockwise. That makes it easier for them to put the marker on the top and have the top going away from them, so that it's not destroying the marker in the process.
Can you adjust the rotation direction?
You can't change the direction. I could do some extra wiring and change and have basically a double throw switch.
Double pull, double throw switch.
Double pull, double throw switch. I could have a switch on here that would let us change the direction, but I haven't bothered. It hasn't seemed to be an issue.
It's really not a necessary step.
No. All right, this right here is the motor mounting plate, and this holds the motor in place so that it's well aligned with the tailstock. And then it sticks right in here. It's got a channel for it, and it holds it nice and rigid. We have to screw the motor onto it. So it's got 6 screw holes here, and we're just using M3 screws. I'm not using American screws because American screws stink, and they're not very good for precision work like this. And metric screws are great for this, especially because when you're designing holes, you don't need to remember much. You just remember that the hole needs to be 3 millimeters. M3.
Okay.
Let's see, gotta find the right bit here. All right. So we just screw all these little screws in, and then our motor is nicely held and attached to the front of the housing here. That's in there nice and tight. The electronics are in there good. So I think we're ready to call this part done and close it up.
And you said that flexible top is sound deadening.
Yeah, it keeps the sound inside.
Okay.
Does a pretty good job. All right, so to connect this sucker in here, first thing we got to do is drill out these holes a little bit, because if you look closely, the holes for putting the screws in are filled with a little bit of junk. Sometimes the 3D printer at such small sizes doesn't do a perfect job of getting things precise. Okay, so to hold the lid on, I use a captive nut. So this nut goes in here.
Oh, yeah, okay.
And then the screw's going to go down into it.
That's a clever design feature.
It makes it easier than having to go through all the way through the thing.
All right.
Not that lid, this lid. It's got a little channel here to hold this in place even better. So that just goes on with a couple of screws. Again, M3 screws. Let's see, where's my screwdriver?
Okay, so now we have to mount it onto the mounting board. We popped a couple screws in the bottom. And we're going to bolt that in. We're going to put a couple nuts in the bottom.
Yep.
That'll hold it in place, and then we're almost done for this part of the process, other than hooking up the power cord.
Yep.
Okay, so we're bolted down. Motor's working. Very quiet.
Oh, well. Some of these parts need lube so that they move smoothly against each other.
Oh, we're getting into the tailstock now, right?
Yep, we're building the tailstock.
All right.
So I use this sanitary lube. It's for machinery that has food contact. I do this because I figure this is probably the safest lube to use. You could use something like a regular machine oil or something like that. I don't know. I just wanted to be a little bit extra safe. But pretty much anything that's good for machinery to move well against each other will probably work good for this purpose.
Okay.
So the parts that I've lubed up are mostly the ones that just are in contact with each other in the tailstock. So this is the tailstock quill itself. I added a little bit of lube here for these parts that'll be in contact with the inside of the tailstock. And then I wiped most of it off. You don't really need much, just to help the 3D printed parts slide against each other a little bit better. And as you can see, this is moving pretty well. And then, of course, this part right back here is going to retain this bolt. So this bolt right here goes in here, and then this is a retainer for it, and these parts will need to slide against each other as well. The more this gets used, the looser and slidier it will get. So don't worry too much about being perfect with this. As it gets used over time, it will become easier to use. So let's go ahead and put it together. To retain this tailstock bolt, I have this retainer here, which is what I'm calling it. I don't know what an industrial machinist would call it, but I'm calling it a retainer, a bolt retainer. So that goes on like that to hold that to the tailstock body, and then I'm going to use M3 screws to hold that on. So I'll go ahead and get those. All right. Make sure that that's long enough. It is. We're going to use some washers as a spacer. We don't want the tailstock bolt to get pinched. So, all right. Now that we have this bolted down and tightened, you can see that the bolt spins.
Yep.
And now we can put the quill in. Get that in there. We also want our knob. Here's our tailstock knob. And then we can advance that. Pull that in.
And once we have that, all we have to do is bolt it down like we did with the motor controller onto these 4 holes.
Yep. All right, now we're ready to bolt this down. And I've got these channels here so that we can make sure that the alignment is good. You want to make sure that the center of this thing is aligned well with the center of this thing. Yeah. We'll do a little bit more alignment later. Okay. But we'll do some initial alignment now. So
in this application, it's really not that critical since we're just coloring. We're not turning a pen on it, which would be very critical.
Yeah, right.
But since we're just coloring it, it can be a little bit off. But we've got this these slots in here. So we do have some flexibility and adjustability.
Okay, for the live center, we need a bearing that will spin and hold the tip. There are good bearings and bad bearings to buy for this. This is one of the bad bearings to buy for it. You can see it's got this plastic shield here, and it's got a lot of play in it. It kind of wiggles around. So you want to get one of these better bearings. This is a 608Z bearing from Singapore. You can buy these on Amazon, but you can also buy them from McKesson or McMaster Car. And this one is tight. You can't really wiggle this one around in the races. You want one like this because the tighter it is and the better it runs, the more stable the top will be as you're spinning it, and the kids will have a better experience.
Oh, so that's just a press fit?
Yep, just presses right in. So this is the most essential part. I had been 3D printing these chuck pieces to start with, and I found that the tolerances were really bad. The tops tended to wiggle around a lot. So I ended up turning them out of a really hard wood. I used buckthorn. You can use whatever you want. As long as it's hard, you wouldn't want to use something soft like walnut or pine.
What did you use?
Buckthorn.
Buckthorn?
Buckthorn, yeah.
I don't know what that is.
It's invasive.
Okay.
Yeah. So this part right here goes onto the spindle end, and it has a screw here that I've tapped a hole for to hold it onto the flat side of this this spindle here. So I just tighten that down to hold it in, and then this part right here goes into this end. I've got this bearing here, but you can see that it just goes through. This is a 7mm hole through the bearing. So you can just mount a piece, turn it, and you want a cup shape like this that's pretty deep. So this is going to hold the handle end of the top. And it's a cone shape so that it can accept all sorts of different shapes of tip here.
Right.
And then at the end of this one right here, you can see there's a very small cup that'll hold the tip of the top. And that's that. All right.
Okay, so here's the final product. We have a top all chucked up here. We're going to power this with a little Jackery power supply. And then we need some markers that we get at Amazon. I think get all these markers. I forgot how many in there. I've got one of these also. Like 25 or 30 bucks, you can get that many colors. And now we're going to do some coloring.
Yep, we'll turn it on.
Turn it on.
Hold on. Turn it on. Oh yeah, there we go.
So we got speed controller over here.
And Bob's going to do some turning.
Yeah,
He's going to do some coloring.
Time for Bob to have fun. Ready? So this is my favorite part. I like using hot colors. So I'll use red, orange, and yellow. In this application, we don't really need a banjo. And it's going to be that simple. So what we found when we're doing this out at the different shows, kids really like to do this. They get a big happy smile on their face. But even more important are their parents who are taking videos of doing this. And they really seem to get a kick out of it. All right, Bill, I think this is working out really good. We're going to wait a day or so, and we're going to be using this at the Environmental Center on Saturday. So thanks for inviting me down to your shop, Bill. I think this is a winner. I think it's a great little project, and thanks for doing it. Yep.
Defying gravity.
Yeah, that's what the New Jersey woodturners are all about, making these tops for charity.